Okay, so here's some help with 411. I wanted to get you started. One, I forgot to write these colors on here before I copied them. So fix yours to match mine, then you can actually answer this question. So remember, experiment is something like spin a spinner, or roll a die, or flip a coin. The sample space is all the things that could happen. So your sample space in this case, usually we use curly braces, green, blue. That's all the choices that we could have. Black, white, yellow, and red. Right? It's all the choices. Define the event. What's the probability to land on blue? So land on blue. Solve for probability. You write it like this. Probability of blue is how many blues are there? 1 out of how many choices? 6. So you always want what? Good over total. So 1 over 6. We normally turn it into a percentage too. So just, type it in your calculator. 0.16666. And really, I like to just turn it into the nearest whole number because you sound pretentious if you said 16.7% chance. You just say 17% chance. Most people have a good idea of that. All right, next one. Probability of flip coin landing on heads. Oh, that's real tough. Just kidding. But get used to writing it. Probability of heads is 1 head out of 2 choices, which is a 50% chance. Unless you're talking to me, because I can flip these things all day and land heads. I'll show you how later. That'll be a how-to. Oh. All right, what's the probability of landing a coin 4 times out of 6 trials? Now this is the tough problem. This is very similar to question number 10. Yeah, question 10 on the very back. So this is a tricky question. It's called like the Bernoulli type question. Basically, here's a formula you can use. Whenever you have some amount of times out of some trials, here's the formula. Okay, so let me explain this thing. So NCR is called, first of all, in probability, we call it choose. This should be the number of trials. This is the number of success. So number of successes, number of trials. This is the probability of success raised to the power of the number of successes you want. This is the probability of failure raised to the number of failures you want. Okay, so let's look at this. If I flip a coin 6 times and I want 4 of them to be heads, it doesn't tell you that it wants it to be heads, 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 tails, tails, or heads, or tails, heads, 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 tails. So there's lots of ways you could get 4 out of 6. To take care of all those ways of getting 4 out of 6, you use this thing. There's a fancy formula for it in your notes, but it's just easier to use your calculator and write 6 throws, choose any 4 to be heads. That's 4 times out of 6. 6 choose 4 is how you pronounce it. On this calculator, you can find it under PRB for probability. Crap. And see it there? But the problem with this is you actually have to type the 6 in first. 6, probability, choose 4. And there's 15 ways to make 4 out of 6 things turn heads. So, now what's the probability of success? What's the probability of a head? That's 1/2 raised to the power of how many heads do I want? 4 of them, right? Times the probability of failure. What's the probability of tails? 1/2. How many times do I want tails to happen? Out of 6, I only want 2. So this is how you'd set up your problem. This problem's a lot more interesting if you're rolling a die, because think about it. If I roll a die, the probability it lands on a 3 is 1 out of 6. So here for success, you'd say 1/6 if my goal was to roll a 3. I would say 1/6. If I wanted to do it 4 times, I'd still have that 4 power. Now the probability I don't roll a 3 is actually 5 out of 6. So these numbers are not usually the same unless it's 1/2 and 1/2. Okay, so I'm going to type that in. So 6 choose 4 times parentheses 1/2 to the 4th times 1/2 to the 2nd. Boom. It's a 23.4 or 0.234 chance, which is really about a 23% chance. Okay, now on this calculator, you can find it under math and see how probabilities right there. Prob, just scroll over. And there it is. This one's nicer because you can just type it in how it looks. 6 choose 4. And then you could get the same thing. Still 15 ways. Anyway, that'll help you on number 12 or number 10 near the end. All right, let me move on. All right, now we get to this part. This is where you actually have an experiment. So you have 2 choices here. You can either go to the web page, right, and use the random coin flipper, and that's a website that flips coins for you, or you can actually flip a coin. I got some up at my desk if you want to go get it. And I'm going to flip it 10 times and see how many heads and how many tails I get, right? So pretend I did this. You know what's kind of weird is people usually don't count on how many times in a row you can get the same thing. Okay, so let's pretend I did this. Let's pretend I got a couple of those and then a couple more. Oops, can't get the old heads tails. So let's say we did this. We got 7 heads and 3 tails. So relative frequency is fancy for if probability is what should happen, relative frequency is what does happen. So the relative frequency of heads is 7 heads out of 10 total. Now, that's 70%. Should it have been 70%? No, it should have been 50%. But life doesn't work like that, especially if you only do 10 flips. You think doing 10 flips, it's really going to come out 5 out of 5 every time? Wrong. So you're going to do this just to see if you hit 50 or if you're off. Now, the next part, this takes a while. Hopefully in the first day you can get all these done. Toss a coin 50 times and record its heads and tails. So it flows over on the next page. Now, why I want you to do this is because on 50 trials, I want to see if you're closer to the right percentage, because 70% is pretty bad. But I bet when I do it 50 times, I get a little bit closer to 50%. And then, even better, we're going to get the whole class data, and you're going to put it up on the board. See, I put that there? Yeah, put your own results on there and add them up, and you're going to get the entire class data of probability on landing on its heads. And if there's 9 of us, we're going to have like 450 flips. That's going to get closer and closer to 50%. Granted, 450 flips is not a crazy amount, but this is called the law of large numbers. And it's a neat thing in probability as it says, let's say the probability of flipping a head is 50%. If I do an experiment enough times, the relative frequency, what does happen, gets closer and closer to what should happen. That's called theoretical probability. So if you did this head coin flipping experiment a million times, I bet you'd be really close to 50%. If you do it 10 times, you're not going to be close to 50% a lot of times. But even with all our class, you'll have some people above 50, some people below 50. And I think total, we should probably get a number pretty close. I already put my numbers up on the board. Good times. Okay. If I did it with a die, like the probability of rolling a 3 is 1 out of 6. If I roll this 6 times, it doesn't mean a 3 is going to come up once. Now, if I rolled it 10,000 times, it would get pretty close to that correct probability. So that's called law of large numbers. So try that out. You can use the simulator, or you can come up and use a real coin. All right. Now we get to the stuff you're probably doing on day 2, and that is creating a histogram of all the possibilities of rolling 2 dice. Now, if you roll 2 dice, the lowest number you can get is a 2. The highest number you can get is a 12, right? A 1 and a 1 is 2. A 6 and a 6 is 12. So there's the event is, I'm going to write it like this because I don't feel like writing and between them. If there is only one way for that to happen, right, I'm going to write a 1 here. There's only one way for that to happen. Now rolling a 3, I'm going to change colors here. Rolling a 3 is actually easier than rolling a 2 because check out the 2 different colored dice. I could roll a 2 and a 1, or I could roll a 1 and a 2. And you can tell if they're different colored dice. This is a different roll than that. Okay, so there are 2 ways to roll a 3. And similarly, if I roll a 4, it could be a 1 and a 3. It could be a 2 and a 2, or a 3 and a 1. Just consider my 2 dice are different colors, right? Okay, so there's 3 ways. 5, kind of similar. So I'm going to pause and kind of let you do that. Do that, wait a minute, and then check with me. All right, so hopefully you did that. You can see the most likely number to roll if you have a pair of dice is a 7. The frequency is 6. Now the probability, if you added up all these possibilities of what I could roll, there are 36 different outcomes that could happen with this if you counted all these up. So it's really, the probability is different than saying the frequency. So it's like 1 out of 36 probability of rolling a 2. 2 out of 36 probability of rolling a 2, right? And here is 6 out of 36, or like a 17% chance. Anyway, you're going to make a histogram. Just the frequency is the y part, and the x part can be your sum of the dice. Right? 4, 5, 6, 7, 8, 9, 10, 11, 12. Always label graphs. But yeah, the bar is going to be like up 1 for your first one. Then up 2, and you can see the probability. So the probability of rolling a 7 is, there are 6 ways to roll a 7 out of 36 possible ways to roll the dice. And you can keep doing that. Be careful on some of these, right? It's probably not rolling a 9. I'll let you figure that out. And then you're going to roll dice 50 times. Now you can either use the simulator, or you can come up and get some dice because it's more fun to roll dice, right? And this is weird because, like, let's say I did this. I'd want 2 different colors so I can actually track them. So I want this to be, die 1 is purple, die 2 is white. So this would be a 3 and a 4. And the total is 7. Right? And then I roll it again. I get, the white is 3, the purple is 1, so that's a 4. Right? And you're going to keep going and going and going. The reason you're doing this is at the end, it asks you some relative frequency questions. The sum of 7, you just have to count how many out of 50 came out to be a 7. The relative frequency of rolling a 6 on a single die, I would have to go through and be like, okay, I'm going to count all the 6s that happened on P and all the 6s that happened on W, and that's actually out of 100. So be careful in that, because a single die is on 100, not on, actually it wouldn't be out of 100, it would be out of 50, but you'd have to count how many of your rolls did a 6 just happen on one die. I think on the way that's written, if you rolled it on both, it wouldn't work. So yeah, try that out. Let me know how it goes. I put some help on number 10 and 12 if you need it. All right, talk to you later. Adios, people.